Welcome to the Asset Intelligence Framework Masterclass. I'm Robert, and over the next 18 sessions, I'm going to show you how to transform your manufacturing or utilities operation from a cost-heavy burden into a high-performance financial engine. We start at the top: investment prioritization. In the industry, you will hear terms like lifecycle cost analysis or strategic asset management planning under the ISO 55000. These are often treated as separate paperwork exercises, but in this masterclass, we merge them into a single unified lens: the Asset Intelligence Framework. Why? Because most companies look at what an asset costs to buy. We look at what asset generates over its entire life, adjusted for risk. If you are still making investment decisions based on the lowest code, you are already losing. Today, I will show you how to pick the winners using intelligence, not just intuition. Standard industry practice is to look at the initial purchase price and estimated maintenance. That's 20th century thinking. It ignores the strategic asset management plan, the bridge between your corporate goals and your technical reality. The Asset Intelligence Framework uses zero-based capital logic. Every dollar of CAPEX must justify its existence against the cost of inaction. In ISO 55000 context, this means aligning every pump and every transformer with your organization's ultimate value definition. If your corporate goal is 99% reliability for a critical utility grid, your investment strategy shouldn't just be about fixing what's old. It should be about optimizing what's critical. We don't just ask, is it broken? We ask, does this asset's current health risk our strategic plan? Imagine you have two projects competing for a $500,000 budget. Project A is a capacity upgrade to a packaging line. On paper, it promises a 10% increase in throughput. Project B is the overhaul of a 20-year-old compressor that has been showing silent sign of fatigue. Most managers pick Project A because growth looks better on the spreadsheet. But the Asset Intelligence Framework applies the SAMP. We look at the data and realize that the compressor is a single point of failure for the entire facility. According to our strategic plan, our top priority is continuity of supply to our Tier 1 customers. The compressor has a 35% probability of a catastrophic failure this year. If that happens, the new packaging line from Project A sits idle anyway. Under the Asset Intelligence Framework, Project B isn't just an overhaul. It is a risk mitigation investment that protects the entire plant's revenue. Let's look at the numbers for Project B. Cost of project, $500,000. Cost of inaction, $2.2 million. This includes 4 days of total plant downtime, emergency freight for parts, and the loss of a key contract due to a failure to supply clause. By spending the $500,000 now, you aren't just spending money, you are buying a $1.7 million insurance policy. That is how you present a maintenance project to a CFO or management. To see the true power of asset intelligence, let's look at a scenario involving a high-stakes processing plant. Imagine a facility where the sales are surging, and the board believes that they hit 100% capacity. They are currently reviewing a $20 million CAPEX proposal to install a second mixer. Before signing that check, an asset intelligence audit looks past the rated capacity and analyzes the physics of the thermal cycle. In this model, the bottleneck is a large industrial heat exchanger and mixer. The consensus is that it's too small because the system waits for a 45 minutes cool down phase between every batch. But by analyzing high frequency thermal data, we often find that this wait time is actually information latency. Standard probes are often placed in dead zones, providing a temperature reading that lags 15 minutes behind the actual state of the liquid. Instead of a 20 million new equipment, the AIF solution is a 1.2 million intervention, a high accuracy sensor array, and a predictive cooling algorithm. By anticipating the target temperature, we can start the next cycle 20 minutes earlier. The result? A 22% increase in daily output. That 22% is the volume both thought can be achieved with the second $20 million machine. We found a 10 million factory inside the existing walls for a fraction of the cost. We used intelligence to replace capital. Your homework for the session. Take your current project list. Don't look at the price tag. Calculate the cost of inaction for each over the next 36 months. If you don't do the project, how much money leaks out of the building? In the next session, we are going deeper into the capital allocation metrics. I'm going to give you the template to present these numbers to the board. I'll see you in Module 2.